Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the NPTEL course on Remote Sensing and GIS for Rural Development. This is week 11, lecture 2. We are coming close to the end of this wonderful lecture series where I have been getting a lot of comments on how easy it is to use remote sensing for applications for rural development. And as I said earlier, I've met a lot of people who have expressed their interest in this course and multiple other ways that could be used for collecting data and working on rural development. On this note, I have also looked into certain aspects that are new for rural development, and we'll be discussing this in the current lecture series. So while we are on the penultimate week 11, I will also showcase one aspect of data collection that is less acknowledged and less used at the real world. However, wherever this methodology has been used, has created considerable impact. Of this, I'll be first talking about the synergized mapping. So let us go into this remote sensing and GIS for rural development, week 11, lecture 2, where we will be looking at data from other sources that have been used for rural development. Let's say, for example, we have looked into this pretty much in detail. What is synergized mapping is there are multiple players, multiple agencies that come in and help to map the data. And there are institutions and NGOs that create capacity, training, and update the knowledge of people through on-the-ground exercises. And farmers, stakeholders, rural communities are those who actually engage with the data and the results, because it is for them this data is collected and used. So we have looked at satellite and drone data, but now we're going to look at crowdsourcing plus satellite data in a synergized mapping scenario. In this scenario, what happens is a lot of data can come through. However, not all data can be in a usable format. It is because there could be some data issues, quality issues, what data is being collected is not clear. So we will look into a schematic where actually this has been done at scale, and a lot of people have been using this for the past 10 years. So of the crowdsourcing data collection method, let me introduce what crowdsourcing means. So crowd is the general public, and sourcing means you are sourcing the data from them. For that to happen, there has to be a platform that is given to the locals or crowd, we call it here, and they participate voluntarily. There's no payment here. Like, for example, they have to give data and then they get money, or it is not a mandate for them. This is purely voluntarily done. So what we have here is a group of people who are cautious about the system, what they're monitoring, and they collect data and upload it or share it to the platform. So the platform has to be robust enough to capture the data and then put it at a larger scale. For example, the farmers might give data on the crop growing scenario. Is it at bud stage? Is it at intermediate stage? Is it at fully grown stage? So these stages can be monitored and then given back to the crowdsourced platform. Let's say, for example, we have a database I've created where we can put the data and then see if It triangulates with what is happening on the ground, like other satellite data, like rainfall, land surface temperature, NDVI. We can triangulate if the data is working, and or if the government schemes are addressing these issues. For example, the Jal Jeevan mission is there, where every house in the village is to be connected through a tap. And also there is the grid scheme, where across India, the rural electrification program has been well received. But the quality could be compromised because of other externalities. So the pipe might be there, but water coming in or not is very, very crucial. And that relies on the resources available. So how do we monitor it? It is very highly impossible to put meters everywhere and then monitor it, given the population we have. So the best way is to work ground up. So all the other data is top down, where we call it top down approach, where the government collects data through the system and then takes it back to the top and then analyzes it for policy. When we talk of bottom up, the people, the crowd who's at the key stakeholder level, they will collect data and then put it up in the system. So how is that useful? This is useful because the data goes from the user's end. For example, I am drinking this water, so I should be able to know what is the quality of the water, because is it affecting me, healthy, etc., rather than trusting the supplier who's giving me the water, right? So this, at the supply end, there could be a data collected from the tap, how the water is coming, the quality. But at the end user, how is the water quality I should be able to give? And this helps in intermediate issues that can happen in the water supply. There could be leakages, there could be mixing of dirty water in drinking water, etc. So all these can be done if the end user gives the data. So census is an end user data, right? You don't monitor from the top. People go door by door, collect the number of people living, number of households, and then issue the data. And from there, the electoral data is created, and from there, your population is also assessed. These are important scenarios for any government to develop, both urban and rural. But very much it is important in the rural entity, because at the rural level, what happens is we have to have clarity on the data. We need to have better infrastructures planned, and for which you have a lot of data that is needed. In the cities, it is almost easy to collect because the representativeness is there. There's a community of houses, so one house reflects all the other houses. Whereas rural, it's not. It's very, very scattered, and hamlets are there where a group of 30 to 20 houses would be there, and then suddenly after that, there's a big land of agricultural land, and then another 20 houses, 30 houses, 10 houses, etc. So to address this, the best way is to go bottom up, where crowdsourcing is key. And I've been advocating this a lot, because if you use open source software, open source instruments, then you could definitely collect data at a very, very high spatial and temporal resolution in rural villages for the fraction of the cost. For example, the farmers can take just an image. They don't have to use an app to take an image. Already the camera is there in the smartphone. And almost 90% of people have smartphones if they can afford it. Like economically, along the average line, there are multiple phones now available which are not that too costly and does the job. So one quick check of the fact is that you do see a lot of TikTok videos and Instagrams, Facebook videos, YouTube videos from villages, and all of that using smartphones. You don't have to have fancy devices. So moving on, there is potential to collect data and put it. So now why don't we use this for geospatial location data? GIS data is the key. And this is what a company has been working on and looking at this data in a long-term fashion. Let us look at this in a app that has been created in recent times. So OpenStreetMap has been widely used. It is a very sophisticated system. We will discuss this system in today's lecture and also download the plugin in the QGIS software and see how it works and reflects the data. So I would like to install the plugin in the current series, and then we will take a call on how this map works. So what we have here is OpenStreetMap is a tool that everyone uses for looking at certain data that has been collected and shared by public. So what is OSM? It was found by Steve Coast in 2009. It is a free open geographic database. It has data attributes, we call them, right? So some data about whatever locations, amenities, schools, crops, everything. Okay. You'll be amazed to see the quality of the data. Not all data is there because this is not run by a organization to collect data. It is free open source volunteer data. So only if people pitch in data, you will get data. So let us look at this at a very close angle. My point here is when I say that all area is not covered, the point I'm trying to make is most of the data is covered and we'll be able to use it wisely if we know that most of the data is covered. So starting with no data, at least we have a data that can be used. That is the question. So we will be able to look at in the next lecture a particular state and a particular district. We will download the map and then we'll apply it in this OSM software app. We'll install this plugin in QGIS and then we'll extract data. So this is based on community of volunteers, this data collection. Initially, it was very small in 2009 when Steve Coast had started it, but slowly the momentum grows. So like any other company, any other product, it starts slow, but then when people momentum start, a lot of data comes in. The data quality could be an issue. I will open this link pretty soon now. And it is really licensed. But again, let's not talk about the negatives right away. There's a lot of positives. I would say that this is one of the highest updated data that any government would like to use because it comes from the bottom, not from the top, where top down is you will send a person to go collect data. So he or she will travel, go collect data, and then come back, sit and map. It takes time. Whereas here, with the click of a button from the volunteer, it comes straight to the location database, and the volunteer is already sitting in the village. So you don't need to have super time taken for these kind of activities. So let us open the free OpenStreetMap.org and what we'll be looking at is we'll be looking at the data set, the metadata about the data. As I usually am telling you that it is very important to have metadata for all the data products that we have. The boundaries may not be correct because they may use different boundaries, but we are more important and we are more focused on the attributes. Okay, so let me quickly open it. And while we go to the website, this is the OSM plugin that I'd like you to install. I hope you know how to install it because we have given you the tutorials on installing plugins. However, if there is time enough, we could also show quickly how to install the quick OSM. So I will go back to this opening this links. Please allow me to share. Right. So this is the first link. When we open OpenStreetMap.org, you have the map coming up. You can search a location. So let's say you can search Pune, as we have been doing for the past lecture series. Yes, I would like to see the Pune, and there's multiple other things in Pune, but let's go here. Okay, so here you have the boundaries also. So fixed admin boundary for Kalyani Nagar, fixed boundary for Pune. These are the data that are there in different languages. Also, you can have and in Tamil also it is showing. So there are different languages and parts available. Okay, so this is the one when you open Google and then search for OpenStreetMaps, most probably this will come up because this is the basics. You can say learn more and then see where it goes in terms of who's the local knowledge and then how the community is driven. But I would like to show you here. It is hosted and supported by UCL. UCL is the London's global university homepage. So it is actually pretty good that a university is giving these spaces, because someone would have asked me, okay, how do you get uh, a big database and managing the database? All of that is done in this UCL, which is good because some these cannot be by itself done. So UCL stands for University College London, and a lot of research activities have been done here. You could see that the database it stores is pretty historic, and it'll actually do a wonders because they cannot afford to do it. As a volunteering company, you cannot afford to do all of it, right? So, and also this is supported by Fastly, Bitmark Hosting, and other partners. Bitmark Hosting is also a cloud space, but other partners are also there. So let's first acknowledge all the partners. From the many support, have been supporting OpenStreetMap from the beginning at the Bartlett Center. I'm very grateful. Bartlett Center is the hopefully the data center that creates all these locations. Our built environment is having some data input and data access. Fastly, Bytemark for many years have been extremely helpful for supporting them, and many others. Many others are here. You'll see mostly you don't see the proprietary software here because for them this is kind of not they're just cutting in their business and profit, right? So proprietary software have always business these, whereas this is open source. It is free for everyone to use. You can learn more about OpenStreetMap. So let's go quickly and learn more. So you see the local knowledge. What does the local know about a particular data set? Let's say water body. What is the name of the water body? Everything is contributed. Contributors use aerial imagery, GPS, and low-tech field maps to verify OSM is accurate and up to date. So, for example, OSM might contact you after you give data to show that this image we have taken, can you check if this image is correct? Let's say the Powai Lake boundary. We know that the Powai Lake boundary has been changing because of the developments around the lake. So they'll ask me, okay, is it correct? Is it changing? And then those kind of things we can take from aerial imagery. Then we have the GPS devices. Some people may not have a handheld GPS device to monitor and take data. However, your phones are pretty good. Your phones can take a very good amount of data. So please try to see if you could use your phones for these kind of data collection and stuff. There are multiple apps for GPS. Please look into your Play Store, Apple Store for downloading accurate GPS free open source softwares that gives you the location. And in the location, you can mark school, education, crop type, anything that you can mark. Low field tech maps, so some maps that needs to be updated, and then those are being used. And it is community driven. A lot of passionate youngsters are giving a lot of their time to develop this database. And then they're very, who are they? They are very fond of mapping, GIS professionals, engineers, humanitarians, disaster relief workers, NGOs, industries, colleges, institutes, etc. And OpenStreet maps are free data. OSM is free open data. They're free to use for any purpose as long as you credit the OpenStreetMap and its contributors. I don't see them pull you down. But as I said, it is ethical to thank the contributors and acknowledge them. So please feel free and take it as a duty to acknowledge them when you use their data. So you'll see that all my slides, when I'm using OSM, I do have their logos. So the logo is meaning of not showing that it is my work, it is OSM work. Okay, so the copyright and open data statement tells that it is free and open for everyone to use. So this is very important because a lot of people give money for them, right? So as a free open source system, they cannot sustain by themselves. So a lot of people have put in money. When they put in money, they want it to be not commercialized but available for the people. If they start commercializing, then it becomes a company, and I demand share on the profit, right? So if I'm putting money and they are using for commercial, then I demand money for my services and budget. But here, since it is full open source, pura open source, it is important to understand that there is a need for acknowledging them, and it has to be kept open source. Okay, so legal documents are there if you would like to see, and then these are the partners, hosting partners. Again, UCL, as I said, hosts the data, a part of the data. It's better to break it into smaller bins and then store it. Let's say Asia region is in one database, the US region is in one database, etc. Or some attributes. So they'll say all the schools are in one location, all the hospitals are in another location, etc. So the key contributors, if you see, you would see multiple countries. You don't see India yet. Maybe it's not picking up yet. So hopefully it will pick up. And then there are trademarks for the brand. Awesome as a brand has been trademarked. Okay, so in the OpenStreet communities, if you go to the community part, okay, I'll go back to what is OpenStreet maps. We've learned a lot. So you can see the history of your searching and how people have updated. As I said, in this location, who's updating? So if I change the location and then go to, let's say, Chennai, and then okay, so Chennai is there. 9 months ago, someone has input some data, and then we can go to see the history. In the history also, you can see now the name changes for this region. So the box you see for the box who has input data and how old. So closed about 11 hours ago, someone has input data on accessibility, added elementary etymology data, added buildings. So you can click here and see what buildings were added. So someone added this building in OpenStreetMap, which is really good. And other nodes, locations, etc. can be taken up. Right. So in the history side, we do see a lot of these data. 3 days ago, and somewhere your name and other stuff is being added because they say how many edits, map nodes, etc. So here is where sometimes you may not get very accurate data, but it is your role as a researcher, as a student, to make sure you verify the data because it's open source. People can put data that is not correct and accurate, and that is not purposely done. It is done also because maybe they didn't know the correct way of doing it. So it is up to you to correctly map. So when you start mapping, you'll have to sign up, display name, your profile, and then you can create the maps where you want to put data and other sources. So this is it about OpenStreet Maps. You have GPS traces where it tells you someone has traced a route from drag point, Toyota Prius from a car, and then a lot of other people have done traces using their GPS data. So basically they have taken the GPS location and road and path, and they're putting it into it. So user diaries are about users and how they have mapped, how it has helped, etc. Hospitals, locations. If you see this, it is mostly very useful in developing and underdeveloped nations because you don't have a set agency like NASA or ESA for helping them using remote sensing data. So crowdsourcing is the way forward. And then we have the communities. As we said, we already saw the communities. Multiple OpenStreet communities. We don't have one for India yet. and I really hope a lot of communities can be set up, and users can, like you who are taking this class, can also be part of this community. And then copyright, yes, there is a lot of copyright that can be shared and used. So we can see this. I've already said what are the copyrights that are available for public. You can pick and choose your copyright status depending on how you use the map and for what you use it. The trademark is there. The magnifying glass logo and the state map are registered trademarks of OpenStreet Foundation. We will not go into the OpenStreet Foundation, but understand that it is part of their logo and trademark. Okay. So we will now go into the other aspect. Let me where we have the help section, where we can see like beginner's guide, help forum, mailing list. You can be part of the community. You can open the OpenStreet map wiki to look at documentation about the OSM. So you can see here the beginner's guide, developers and users platform, etc. So this gets back to your browsing the OpenStreetMaps, how to browse, what are these low points. It's like a tutorial for you to use and then use it for your learning and understand. We'll do some quick tutorials. I believe in doing it and learning it. So it's better to do that way also. Okay. Good. So we have come here and then we also have other platforms, forums, asking questions. So normally, as I said, there is a lot of open source community helps where people just help you to do it. So for example, here, show coordinates on map, download international boundaries. So maybe someone has an issue in downloading. Completely new with OSM, I try to download all international boundaries. Is that possible? And yes, how? And then the answer is given soon. So yet the answer is not given because it's a very recent question. Let's go to some questions. The answer is there. Routing distance from OpenStreetMap. So someone is asking, I use OSRM backed API to regulate routing waypoints, but they have a user limit. What should I do? You can set up the graph hopper or OSRM on your infrastructures, then load the PBF file for calculating the distance. Okay, but the point here is so basically any questions you have, if it is a legit question and a serious question, they will be answering it because people take their time looking at it and answering it. So let me before we go to the next session, I would like to open the plugin and then show you how to download your plugins because that is very important at this stage, for which you will have to make sure you know that is it useful and do you have the bandwidth for keeping the stored data in your computer. Okay. So with this, let me open my QGIS page. So let it open in the background. I'm going to open my QGIS. While we go back to the previous slide, and then open this link. Okay. So we will also look at the files, the metadata as promised. Let me open, so which is here in the page, bottom right. I'm going to open the Planet OSM, which is the metadata. Download space are currently restricted, so you can download the data. So here's where you can learn about the data and download the data. So latest torrent file on data that has existed, 125 GB created 2 days ago. Latest weekly change sets, all in a torrent site. You'll have to use torrent to download it. And again, this is if you want to download the entire data. But I'll be showing you without this how to download the data as a QGIS package. So for that, let me open my QGIS and share with you. So, okay. So I'm going to share my QGIS. Yes, we have my QGIS. And yes, we share my QGIS. So what you see here is an empty slide. I'm going to go to plugin, manage and install plugins. It will first open that pop-up which says I'm going to download the repository, let it download, and then this happens. So in the installed, I have all these installed for my previous maps. Now I'm going to type Q quick OSM. Okay, so quick OSM is the tool that we'll be using. So let's first read about it here. Okay, so it says download OSM data thanks to the Overpass API. You can also open local OSM or a PBF file. This is also the logo trademark by them in terms of using it for data. Parser top OGR is used to let you see all the OSM keys. 250 ratings, look at the number of downloads, literally a lot of downloads. And then the tags are OpenStreetMaps, etc. So OpenStreetMap is what we want. We will click it, and then once this happens, we say install plugin, let it install. Depending on your internet speed and internet bandwidth, it will take some time. Okay, so now it has done. So quickly, this will get updated. Just see it. Okay, here is what happens. Plugin installed successfully, and we have the QSM page that we have. So it says the version. So initially these were not there. Now it says 2.1.1 updated August 21. And these are the versions. Add a warning key. How this is improved than this. So we had 2.01, 2.10, 2.1.1. We're going to use the recent one. So this is about learning on what are the issues in the previous and how they fix it. Fix an issue with installing quick QSM plugin, good, and then we'll close it. So now if you go to vectors and then see the vector tools, you'll see QSM. Okay. Do not open this now. We don't want that. But QSM is what we'll be using for our lecture in the next lecture, because right now let us set it up, and I also wanted to show you something that is needed for collecting data quickly from OSM. So I'm going to add my India layer. So we'll go here in my GIS layers we have. So I already have some data that is downloaded for this class, but I also want you to download some data that is very important for you. Let's say you're going to download a particular database which is having a lot of information on your project. So let's say you're going to do a rural project in India, Tamil Nadu, and within that particular district. So how do you go about it is the question. So here we will look into a particular database, and then we'll see if how we could download the data, use it in the following ways. Okay. So I'm going to now download first attach my district and full states. I'm going to show you quickly how to take data. So this data was taken from a previous geological, the Survey of India data, okay, the previous version, because I was doing something previous before the Andhra Telangana was divided. Okay, so you could see that the full Andhra is there. So this was used for my particular research interest, and then you also have vector data. You can add more vector data. Click on what else data I have. You have India district shapefile. Okay, I'll add India district shapefile, add, and then you'll see the whole of India with my districts. Okay, so let's say I need a particular district. I have a particular district in mind that I would like to use for my analysis. So I'm just going to open my attribute table. You can search for it using the search box, or you can actually, if you know the district name, you can come down and then look at it. So this is the name 0 is the India level. Then you have the state level. and then you have the district name in here. So let's first click the button here. So once you click the open attribute table, I think my open attribute table is not visible because of my screen. So I hope now it is visible. Yes. So all I've done is I've opened the India districts file, and then the open attribute table has come. I had clicked the name 0 is India, name 1 is state, and then name 2 is your district. So I clicked this arrow mark so that it does it into alphabetical order. Let me do it again just to show you how to do it. I'm moving the layer. I am adding a vector layer. Okay, now the vector layer has been added. I'm going to open the open attribute table. Okay, so this is a name is state name, 0 is India country name, and then the district name is name 2. So you can see that randomly it has been arranged. Let me click that button and then it goes up. So now I want P, so I'll let me come down to Trichapalli, because that is what I am going to use for my study. ST. Okay, so we have Thenur, Tanjavur, starting from here, Srirangam, Thuthukudi, Tiruvallur. So we can just come down to see which districts that we want to use. So Tiruchirappalli is what? So right here, I'm going to click it. So that whole line is being selected. So now if you come down and then see the district has been selected, correct? So all you have to do is right click, export, save feature as. In this page, make sure this is clicked, save only selected features, because you have clicked a entire district shapefile. We're not going to do the entire district, we're only going to do a particular district. So I'm extracting it, it's kind of extracting. So I'm going to say that I'm going to save it as Trichy, the short form of Tiruchirappalli. So I'm going to save, and then the default other things are default can be say add save file onto it. Yes. So now if I remove the India district, so you still have Trichy. Okay. So the idea is you can take a whole data set and from there just extract what you want and keep it ready for your analysis in the next class. So OSM does require this aspect, a shapefile to feed in, or you can use your internet and then use OSM to have good data extraction. So with this, I will stop here. I'll see you in the next class. Please be prepared with the OSM plugin and also some shapefiles of your interest. Thank you.